So this question 13 is has to do with the log equation that we learned on page 100, right? The question 28. Okay, so we want to isolate the x. And to do that, because this one, the base are not the same, right? So we cannot make it the same base. So the way to do this is to do log on. Okay, once we bring the log into the equation, then we have more tools to use, right? Because we have all the log laws to apply. Okay, so if you look quickly through the steps, first step, we put the log on both sides, and then we bring down the exponents. After that, we multiply in to the log, right, to get rid of brackets, and from there, just isolate the x, okay? So let's look at that question again. Okay. Here. So if I bring the log on both sides, it will look like that. Okay, and Waylon, what do we do next once we put the log on?
Do you move the 2x plus 1, like the exponent, to the front?
Yes. Okay, and remember you need to have brackets. Okay, so it will look like 2x plus 1 multiply with log 3. Remember, log 3 is one single number. Okay, you cannot separate the log and the 3. Okay, 3 is inside the log. And then log 2 by itself. Okay, what do we do next, Chen? Let's ask Susan, what do we do next? Susan, are you there?
Yes.
Yeah, okay. So after we bring down the exponent, what should we do now?
Could you give me a hint?
You want to get rid of the brackets of the 2x plus 1.
Do divide?
You want to get rid of the brackets. So usually we want to expand the brackets. Think about if you see this equation, if you have 2x plus 1.
Does it become log 3 2x plus log 3 1?
Yes, yeah, okay. So you multiply in the log 3, okay? Just like on the right side, right? You expand the brackets. So usually we put the log 3 at the back, okay? So you write log 3 first, sorry, 2x first, and then log 3, and then 1 times log 3. So that's log 3. Okay, and then, so after you expand this, right, then you can start to isolate the x. X is only here, right? So you want to move everything over except x. All right, so back to you, Waylon. What do we do now? How do we isolate the x from here? What's that?
Give me 1 sec.
Okay.
Do we isolate the x, like the 2x log 3 by moving the like the log 3 to the other side?
Yeah, then if you move it over, it becomes,
Log 2 minus log 3.
yeah, log 2 minus log 3. On the right side, left side, you still have 2x log 3. How do we continue to isolate the x then? Callum, how do we do the last step?
I think you divide log 3 out of the equation.
Divide both sides by log 3.
Yes.
If you divide both sides by log 3, will the x be alone?
No.
So what else should we also divide by?
Oh, the 2.
Yes, okay. You want to cancel out the 2 and the log 3, right? So on the left side, the 2 cancels out, log 3 cancels out. So your x is left with this part, okay? But then you need to type it into the calculator. I believe they ask you to round it to 2 decimal places, okay? So what you get here, you need to type into calculator and then you round it. When you type it in, make sure you have brackets around your numerator, okay? So it's everything on the top divided by everything at the bottom, okay? So same with the bottom. Bottom has 2 and log 3. Make sure they are in brackets. Because sometimes some calculator, if you don't do that, it won't divide properly, okay? So a safer way is just to figure out the answer for the top, figure out the answer at the bottom, and then divide them. But if you want to type everything in, make sure you have brackets, okay? Because I think some of you got the right steps, but it's the last step when you type it into calculator, you got it wrong. Okay, so yeah. Any question? Can you raise your hand if you are okay with this one? Okay, you can check with your own homework. Okay, please raise your hand if you're done. And then we're gonna look at the other one. So number 17 is similar, okay? So you do the same thing, follow the same steps. Okay, Evan, Marcus, and do you need more time? Yep, okay. So we'll look at another one is question number 28. It's a word problem, has to do with the life, right? Double life. This is a quadruple life, okay? Let me add another page. Okay. Okay, here we go. So number 28. First part asks you to write out the function, right? So I know you see the word quadruple, right? So this is telling you every time it gets 4 times bigger. Okay, so this question has to do with the word problem we did last time. A little bit, yeah, going back to page 92. So this is the formula that we want to use, okay? The one on the top right corner. So you have the final, initial, the rate, right? How fast you are going. So over here, we wrote down what kind of rate you will use, right? If it's telling you to use percentage, then you have to use the 1 plus or 1 minus. Either it's increase or decrease. If they don't use percent, they say double or half, right? Then you use different number. Double, you use 2, half, you use half, right? 1/2. And then a new thing in this one is called the life period, right? A special thing. So it's telling you how fast, how soon right? How much time it takes for this growth to happen, right? Or decay, this change to happen. Okay, so the format looks like that. Okay, so the function is referring to that. You need to write that out. Okay, let's go back. So since I mentioned that it's a bacterium, right? Up means one. So you're starting with one. So this is your initial. Okay, quadrupling means gets 4 times every time, right? So this is the rate. And it takes 7 days for that to happen, right? So this is our period. Okay, so when you read the question, you need to think about which number goes where, right? So our formula looks like this, right? Rate to T over P. So we just fill that in, okay? Final amount, we don't know, right? Because it didn't tell you how many days they want, right? Initial is 1, so we can put a 1. Times it by rate, rate is quadruple, so 4 times to the T over 7 days. Okay, the 1 could be there or it could be invisible, doesn't matter, okay? But you must have the left side and the right side to be called a function. Okay, I think one of you wrote only the right hand side, okay? Then it's not a function. You need to have left and right. So that's the answer for part A. Okay, and then once you got a function, you can just use that to answer B, C, D, E. Okay, so question B is asking if it's 3 weeks from now, right? Compared to the number now. Number now is 1, right? So you want to find out 3 weeks later. So if it's 3 weeks, Jocelyn, if 3 weeks, how many days is that? Jocelyn, 3 weeks is the same as how many days?
days.
Yep. Okay, so the T, you will be putting 21, okay? And then you sub it into the function, right? 21 over 7, and you calculate. So whatever, or it's not plus, okay? It's multiplying. Okay, so whatever number that comes out, right? For example, if you get 5, that means 5 times more, right? Because it used to be 1. Now become 5, right? So you have to figure that answer out by yourself. So that will tell you how many times, right? How many times greater? So that's what you will answer. Okay. Now for question C, right? How long would it take for the number of bacteria to double? So this time is asking how long, right? So it's looking for time for the bacteria to double. So if it starts with 1, when it double, how many bacteria are there? Jocelyn? If it starts with 1, after double, how many will it become?
2.
Yeah, okay, so you want to end up with 2, right? So you write 2 for the final. You start with 1 and then to the T over 7. Okay, so the 1, it doesn't have to be there. Anything times 1 just stay the same, right? So you could also just write it like this. And then from there, you solve for T. Okay, the 2 and the 4, you can use the same base. Use same base. Okay, to solve for T. Okay, so you find out what T equals. Then that will tell you the number of days, okay, that it takes for it to double. Okay, and then question D is kind of like question C, okay? Instead of double, it says only 25%. 25%, that means a quarter, right? It's 1/4. So instead of 2, you would have 1/4. Okay, and then from there, you also do the same thing. You make it into same base. Okay, the 1/4 you can write as 4 to the -1. Right hand side is 4 to the t/7. Okay, so from there, you think about how to solve for t. Okay. And then question E. After how long? Okay, so question C, D, E, they are all asking for time, right? After how long will it grow to 8 to the 24? So that's again the final amount. Right, and then you want to solve for t using same base. So 8, we can write it as 8 and 4, they both has to do with same base of 2. Okay, you cannot make it into 4, right? Because 4 to any exponent cannot become 8, right? So you have to make it into 2. So 2 to the 3 is the 8. And then 4, you can write it as 2 to the 2. Okay, and then from there, you carry on to find t. Okay, this is using same base. If you want to review how to do same base equations, like exponent equation, you have to go back to this page. Okay, look at page 87. That page we practice how to do same base. Okay. Let's go back to here. So the time, okay, because the period is 7 days, right? So the answer that you get is in days as well, right? If they change, they say, okay, it takes 7 months, every 7 months, then the answer you get will be month. Okay, so it all depends on the question. It's not always in days, right? So make sure you have the units, okay, when you answer the question, how many days? Okay, please raise your hand if you don't have any questions for this one. So this one is from the homework that you need to hand in today, okay? So make sure you compare your work, okay, with this one. So today we'll be finishing the log chapter and start the new book. Okay, Jocelyn and Nick, any question about this question?
No, I forgot to raise my hand.
Okay, right. So yeah, so you need to complete the steps, okay, to find the t. All right, does anyone else have questions to ask for the homework? Okay, if not, we are starting the lesson, okay? So make sure you hand in the homework before the end of class today. So the last thing that we want to cover is on page 104, okay? It's talking about the log function. So last time we only learned that how to use the log, right? How to change log from exponential to log, okay? But in fact, the relationship between the exponential, which is this one, right? Exponential. And the log is called the inverse. Okay, they are inverse of each other. So if you remember from way back to September, okay, when we talked about functions, inverse, you can find inverse by switching x and y. Okay, and there, when we learned about transformation, right, when you switch x and y, the function, the graph, it can reflect over the diagonal line, okay, the y equal x. Okay, you have to go back to transformation chapter, okay, and the function. But here, okay, we're gonna review how to find the inverse, okay, because it's been a long time. So here, suppose I give you an exponential, right? This is exponential now. Okay, page 104. So they give you f of x equal to, they give you f of x equal to 2 to the x. So we'll start with writing out, instead of f of x, we write it as y. Okay, because it's easier to just write y. So that's your step one, right? Step two, okay, we are following this part. Step one, we write f of x equal to y. Step two, you switch the x and y. So you write x equal to 2 to the y. Okay, and then we are going to do the counter clock to change this exponential into log. Okay, so to change, because when we do the counter clock, we like to write it as exponents on the left side. We're gonna write it like that. Okay, write it like this first, and then we start with this one. Start with the base, right? 2 to the x equal to y. I mean log base 2 of x equal to y. Okay, so your step 3, log base 2 of x equals to y. So this is called the log function. Okay, and the relationship between these two, because it needs you to switch x and y, right, and then isolate the y, then they are called inverse. Okay, and then I think last time we mentioned that whatever that goes into the log must be positive, right? So you have to say x, right, domain, right, domain of the inverse, x has to be greater than 0. So this is the domain. Okay, anything greater than 0. All right, does anyone have questions about how to find inverse? So if you want to change to log form, right, you must turn it into exponential form. Okay, so exponential form looks like this way, right? You have a base, you have an exponent, and then you have other side. Okay, you must keep it in that form first before you do the counter clock. Okay, please raise your hand if you got everything down. Okay. Okay, so the step 3 is isolate y, okay? Right, over here is isolate y. Okay, please raise your hand if you're okay with this question. We're gonna try another one. Okay, so question B is similar, right? Similar to question A, right? The change is instead of 2, we have a base of 1/3. So you keep the base, okay? Do not change 1/3. Instead of x, you have x plus 1. Okay, so I believe step 1 and 2 are pretty easy, straightforward. You guys can try step 1, 2, 3, okay? Go as far as you can, and I will see if you get it right, okay? And then at the end, we need to write domain as well. Okay, so when you finish question B, please raise your hand, and then we'll go over the answers. Okay, Eric, can you tell us step 1? What should I write?
You just rewrite it as y equals 1/3 x plus 1, right?
Yes, very good. Okay, Marcus, what is step 2?
Is it x plus 1 equals the 1/3 1/3y?
1/3,
The power of y?
y. Well, step 2, it says switch x and y, right?
Yeah.
So basically, the x letter, you just write it as y. The y,
Oh, so
write it as,
so it'd be x equals the 1/3 y plus 1.
yes. Okay, so that's what it means by switching x and y. Don't switch the other parts, right? So once you get there, right, you can start to do the counter clock. And make sure the y has to be isolated. Okay, so please raise your hand if you finish question step 3, right? So you start with log, base, right? And then counter clock. And when we do counter clock, usually we put the exponent part on the left side, right? Okay, log of this base 1/3 of x equal to the exponent. Okay, Sophie, do you have the third step?
I have y plus 1 equals log 1 over 3x.
Yeah. Log base 1 over 3 of x, right? You just follow the order of counterclock and then equals to the exponent, which is y plus 1. But because usually we like to have y by itself when you write a function, right? When you see a function, it's always y equals something, right? So for this one, you need to do one extra step, okay? You need to move the plus 1 to the other side. That'd be log 1 over 3x, right? And then plus, sorry, it becomes minus 1, okay? If you move the plus 1 over, it'll become minus 1. Okay, so this is your inverse function. Right, now for the domain, you look at what's inside the log, right? For the previous function, inside the log is x, right? I highlighted. For this one, inside the log is also just x, okay? So the domain did not change, still x greater than 0. Okay, that minus 1 is not inside the log, okay? So when you think about the domain, you don't worry about the minus 1. Okay, so the function, the inverse function and the domain, okay, both together is your answer. Okay, please raise your hand if you finish this one. Okay, so it's always step 1, 2, 3. Okay, just sometimes step 3, you need to do more work on isolating, right? You need to move the plus 1. Okay, please raise your hand if you're done. Okay, so for question C, we're gonna go over together because it looks a bit different. It's still exponential, right? But it has an extra minus 1. Okay, your step 1 and 2 are the same. So let's go over step 1 and 2. All right, Lily, how do we start step 1?
Change the f of x to y.
Yep, so I will write it as y equal to 3 to the 2x minus 1. All right, and then Chris, what do we do in step 2?
You switch to y and x.
How do I write it?
X equals to 3 to the 2y minus 1.
Yeah, 2, 1. So if you compare this step 2 with the other step 2, okay, it has an extra minus 1 attaching to the back. Okay, so this is not a proper exponential form. Remember I said the proper exponential form has to be like this, right? 3 brackets, only 3 parts, right? Base, exponent, and then other side. So that we can do counterclock, right? Because you want to be able to do counterclock. Go this way. Right, and then go that way, right? Write it out in log. So if it's not in that form, you need to still move a little bit, okay? Before you start to do the counterclock. So for this one, in your step 2, you need to move the minus 1 to the other side. I move this over. So you would have x plus 1, right? This is together. equal to 3 to the 2y. Right, so you have a base, you have an exponent, right? And you have everything else on the other side. Okay, so this is the very key step, right? Without doing that, you cannot do the counter clock. So if you want to start counter clock, if you like, right, you can flip it first before you do counter clock, or you can just do it in the head. Okay, base of this equal to that, right? Equal to exponent. Okay, and make sure you need to isolate the y at the end, right? So I'll let you guys complete step 3 again by yourself. And also try the domain, okay? Think about the domain. So please raise your hand if you finish the inverse function and also write out the domain. Okay, should be done by now, right? You just need to counter clock and then isolate y. Okay, please raise your hand if you're done. Okay, Angela, can you tell us what it looks like after you counter clock?
Y equals log 3 to the x plus 1 equals y.
So like this.
Yeah.
So what happened to the 2? Where did the 2 go? There's a 2, right, in the exponent?
Oh, divided by 2.
Oh, okay. So first you turn it into log form. You should still have the 2y. Okay, log base 3 of x plus 1 equal to 2y. And then to isolate the y, you need to divide by 2 on both sides. Okay. For dividing by 2, usually we prefer to write it as half at the front instead. Okay. So write base 3 of x plus 1. Okay, divided by 2 is the same as multiplying by the half. Okay, and Philip, did you get the domain?
Is it x is more than -1?
Yes, very good. Okay, x more than -1. So to find the domain, okay, you need to look at the inside. Inside you have x plus 1. You want to make sure that part has to be positive. Okay, so x plus 1, which is the inside, has to be positive, so greater than 0. and then you isolate the x, then that will give you the greater than -1. Okay, so that's how you figure out if it's not an exponential form, right? Then you need to move it a little bit before you do counterclock. Okay, and then isolate the y. So I think that ABC, okay, basically cover everything that could happen. Okay, so question D, I'll let you try that all by yourself. Step 1, 2, 3. Okay. Make sure your form, okay, the most important step is step 2. Make sure before the counterclock, you have to write it in the proper exponential form, okay, before you counterclock. All right, you can raise your hand after you got the function. So in the homework, I will be giving you several exponential function, right? So you just basically just follow step 1, 2, 3 to figure out the inverse, which is the log, okay? Log function. No, I think someone dropped out the class offline. Let's see. Nick, is Nick here? Nicholas? Okay, if you finish question D, please raise your hand. Okay, I'm gonna call Nick to find out what's going on. Okay, are you guys done? It's been a while now. Okay, let's get some answers. Okay. Caleb, what's your final answer for y equals?
Oh, I got y is equal to log base minus 2x minus 2.
Base minus 2, like that.
Yeah,
And then
x minus 2.
x minus 2. That's all?
Yeah.
Okay. All right. And Marcus, how about you?
I got the same thing.
Okay. Chris?
Uh, I got something different.
Yeah, that's all right. Can you tell us?
I got y minus 1.
You need to isolate the y.
Oh yeah, but then okay, so I got y equals to log negative 2. I don't know how, but I got x minus 3
Okay.
and then plus 1.
Plus 1. Okay. Anyone else got different things? Philip, what do you have?
I got y equals log base of 2 of negative x plus 3 in brackets plus 1.
Okay. Okay. And Jenny, anything different than the list?
No, I got the same as the second one.
Second one. Okay. Right. So let's go over. Okay. These are all very good answers. The thing that concerns me the most is the base, right? You have a base of 2, base of -2. Okay. Also, like there's a plus 1, and then we have answer that's no plus 1. Okay. So we need to find out where they came from. So step 1, everyone should know that already. So I won't ask you, right? Just write it as y equals. Okay, and then step 2, before we do counter clock, right? We need to change into the exponential form. But of course, we have to switch x and y, right? Okay. That should be a y there. Okay, I'm gonna put a bracket here, right? Y minus 1. Okay, so they are together in the exponent, right? Let me create more space here. Okay, so now we need to move things around. So then it's ready to count the clock. Okay, so the things that are movable to the x side, the things that are not part of the exponent and base, you have to move it over. Okay, so I think everyone try to move the 3 over, right? Because there's a plus 3, just like on the question C, you have a -1, you have to move it, right? So plus 3, I can move it. So it become x minus 3 equals to -2 to the y minus 1. So that x minus 3 is on the other side. Now, is there another thing that is movable to the left that is not part of the base? Claire, what do you think? Is there another thing that's movable to the left? CZ?
The one,
The 1? Where's the 1? Which one?
like the y minus 1.
Okay, the y minus 1, the 1 is stuck in the exponent, so we cannot touch that. Whatever that's in the exponent is not movable. Anything else? Any other options?
The negative.
Yes, actually the negative, okay? So that's the tricky part. Because the negative is multiplying with 2 to the y minus 1, okay? Because they did not put a bracket like that. So negative is not part of the base, okay? So negative is actually movable. So when you see a question like this, right, in the beginning, oops, right, in the beginning, the base is only the 2, okay? Does not include negative. Otherwise, they will put a bracket around it. Okay, so we need to move the negative to the other side as well. So this negative, we can multiply both sides by negative to get rid of it. So make it negative x plus 3 and 2 y minus 1. 2 to the y minus 1. Okay, let me shrink this thing. Okay, so once you get to there, you have a proper base, right? Base is 2. You have the exponent, which is y minus 1. You have everything else on the other side, negative x plus 3. Okay, then you can start to do counterclock. So you have log base 2, right? You start with the base of the other side equals to the exponent y minus 1. Okay, and then you isolate the y by moving the minus 1 over. So it'll be log base 2 negative x plus 3 plus 1. Okay, that plus 1 cannot add it with the 3, okay, because it's not in the log. Okay, very good. So we have a correct answer there. So this is your function. Okay, I think this is as difficult as it can get. Okay, because you have more things to move over. Okay, so just I put this at the end for you to remember, right, that if there's no bracket, it's not part of the base. Okay, so if they have something like this, 4 times 2 to the x, then the 4 is movable. Okay, the 4 cannot multiply with the 2, become 8. Okay, now for the domain. Susan, do you have the domain? Oh, I guess right now, because we got the correct function, how about, do you have the same answer, the function y equals?
I didn't, but now I do.
Okay, so can you find the domain then, based on this new answer?
The x is greater than 3.
X is greater than 3. Okay, so let's see if it's correct. Okay, so we need to look at the inside. Right, inside is this thing. So inside must be greater than 0. Okay, so Susan, how do we isolate x from there?
You move 3 to the other side and divide
Yeah,
by
so negative x greater than negative 3, right?
Mhm.
And then
divide by negative 1.
divide by negative on both sides. Okay, so it will become x and become 3. When you divide by negative, do you remember we need to do something with the inequality? What's that?
Flip the sign.
Yes, okay. So this is also very tricky. Two trick here, okay? So you need to flip the sign. So it should be x less than 3, okay, to be the domain. All right, so watch out for the base and also watch out for the flipping of the inequality. Okay, so everyone, please make sure you write this down. You can raise your hand when you're done. So the question can be as simple as question A, right? You just do counter clock and that's all, right? Or it could be as complicated as question D. All right, please raise your hand if you finish all the notes. Okay, Jocelyn, do you need more time?
I'm good.
Okay, all right, so now you know that exponents, right, exponential functions and log, they are inverse to each other, okay? So we can use that idea to figure out the graph, okay, the function graph for log. So let's quickly review what the exponential function graph look like, okay? Remember with this sum transformation, you had to draw the asymptote lines, right? So these are the two basic exponential functions, okay? These ones. Okay, exponential function, so it has a base, and then the base could be greater than 1, then the function will be increasing. If the base is between 0 and 1, like 1/2 or 1/3, right, or 2/3, right, anything that's 0 point something, then the graph will be decreasing, dropping down, right, going downwards. Okay, the other one from left to right going up, that's called increasing. So these are called exponential. So their inverse will be the log. Okay, so now we're gonna compare this with our inverse function. Okay, use those to figure out the inverse function. All right, so back to page 105. So look at this chart. On the top half, these are the exponential. Okay, so that's the review part. The bottom part is the inverse, which is the log function. Okay, so here I chose the base of 2 and base of 1/2. Okay, so anything that's greater than 1, base is greater than 1 will look similar, okay, in shape, because it's increasing, right? This is increasing. Okay, and then if base is between 0 and 1, the function will be decreasing. So increasing and decreasing rule, it doesn't change for the inverse. Okay, inverse, if base is greater than 1, is still increasing. Right, so let's get some points and then show the graph. Okay, so if you can also flip back to the previous exponential graph to copy, right, or just use these ones. Okay, so if it's -2, will be 1/4, right? -1 will be 1/2, 0 will be 1, 1 will be 2, 2 will be 4. Okay, we have an asymptote on the x-axis. This is y equal to 0. So 0 is 1, 1 is 2, 2 is 4. Half, 1/4. Okay. Close like that. 3 will be 8. And if it's half, it will be decreasing, so it's flipping over, reflected, okay, over the y-axis. So it will be going down instead. So start with 4, 2, 1, 1/2, 1/4. Same asymptote line. Half, 1/4. They never touches the x-axis, okay? So please complete the equation of asymptote, domain, range, x-intercept, y-intercept. Okay, raise your hand when you are done with the chart. Okay, just the top half. If you forgot, you can flip back to the previous page. Okay, Evan, what's the equation of asymptote? Evan, are you there? What's the equation of asymptote? Evan, are you there? Can you hear me? Okay, Philip, what's the equation of asymptote?
Y equals 0.
Yep.
Hey, Jason,
Yeah, Jenny.
can you explain the equation of asymptote, please?
Okay, equation of asymptote is where the graph is getting closer and closer to. So in the graph, I show it with the green line. Okay,
Oh, okay. Thank
Yeah.
you.
and that line, because every point on that line, the y coordinate is always 0. So that's why it's called y equal to 0. All right, and Eric, what's the domain?
X equal to all real numbers, right?
Yep, that's right. Okay, so XER. Okay, Evan, are you back? Okay, Marcus, what's the range? Range
This
has
is-
to do with the y, right? So you look at the graph, the y has to be what?
2. Oh, sorry, no. Wait, y equals the anything like greater than 0.
That's right, okay? Because you look at the graph, all the graph is above y equal to 0, right? Above the x-axis. Okay, next one, x-intercept. Chris, what's the x-intercept?
0, 1.
0, 1, is that on the x-axis?
Oh wait, I said the wrong thing. Isn't there no x-intercept?
Yes, okay, so you just say none, okay? There's no x-intercept. Y-intercept is the 0, 1. Okay, can you guys please raise your hand if you finish the chart? All right, Caleb, do you need more time? Okay. I wonder where is Evan. Evan, are you here?
Yes.
Oh, where'd you go?
3级数学。
Oh, okay, all right. All right, so please copy the notes down, okay? And then we're gonna move on to the following graphs. So these are exponential function, their inverse should be log, right? So inverse, the points of x and y are switched, right? Just like the way when we try to find the inverse function, you need to switch x and y. So same with the points. X and y coordinates are switched. Okay, so for example, it used to be -2 and 1/4. It will become 1/4 and -2, right? All the x become the y, all the y become the x. Okay, so I will let you fill in the rest of the table, okay? X and y are flipped. So y will be 1/2, right? And then 1, and then 2 and 4, okay? So use the new table, you can graph the inverse function. So please do both, okay? Both graphs, complete the table of values and plot the points. And you should see the graph is still following the increasing and decreasing, okay? Everything on the left side are increasing, on the right side are decreasing. Okay, please raise your hand after you finish the two graphs. Okay, let's plot points. 1/4 is -2, so about there. half is -1, 1, 0, 2, 1, 4, 2. Okay, so the graph is going this direction instead. Okay, remember inverse and its original graph, there should be a reflection, okay, over the y equal x, right? Like a mirror line. This is y equal x. Right, if you draw both the exponential and the inverse, right, there's a reflection, right? If I put it together, right, reflection. So the asymptote line for this is, it becomes vertical, okay? So the vertical line, the equation will be x equal to 0. Right, continue, finish the second graph, okay? Remember the points are switched, x and y switched. Okay, please raise your hand if you finish the second graph. Right, let's check the points now. So -2 should be 4, -1 is half, 2, right? 1, 1/2, and 1/4. Okay, -2 is 4. I mean, 4 is -2. Okay, and then 2 is -1. 1 is 0. Half is 1. Graph goes this way. Okay, and you'll also have an asymptote line in this direction. Okay, so please complete the following charts, okay, for the equation, domain, range, okay, and also the intercepts. Okay, you can raise your hands, finish the table at the bottom. Hello, Nick. What happened?
It disconnected me. Like my Wi-Fi just went out for like 30 minutes.
Yeah, I know. I tried calling you. Is your phone number the same? Like 6128, your last four digits? Because I was trying to call you and no one answered. Are you there, Nick?
Oh, can you hear me now?
Yes, now I can. Yeah.
Okay, because like sometimes my phone just doesn't ring. I've had that problem before.
Oh, okay. All right. Okay, so basically we finished this chart already. Okay, this graph.
Okay.
Yeah, you can copy this down, this table. All right, everyone, if you finish the bottom part, the asymptote, domain, range, and intercept, please raise your hand. So these four graphs, they are like the, you can think of it like templates, okay? The basic shape, okay? So of course they can change the base. If the base is 5, then you look at the ones on the left side, right? If it's log, then it's the bottom left. If it's exponential, it will be the top left, right? Because everything on the left, the two graphs on the left, the base is greater than 1. And if the base is between 0 and 1, then you look at the graph on the right side, okay? Depending on exponential or log, the shape will be similar. Okay, Caleb, do you have the equation of asymptote?
Oh, it should be, the asymptote should be x is just equal to 0.
Yeah, x equal to 0 for both of them. All right, and Evan, what's the domain?
Is it all real numbers?
Yeah, Oreo number. No, it's not Oreo number. I almost got tricked. Look at the graph. Is the, because the domain is talking about x, does the graph goes left and right forever?
No.
So where's the graph? X has to be what?
Oh, greater than 0.
Yeah, okay, because it's only on the right side of x equal to 0, right? X equal to 0 is like a invisible wall, right? Stopping it. So all the x values on the green line is always bigger than 0. Okay, it's all on the right side. And then the range, what's the range, Marcus?
Y is is it Y is less than 2?
Where did you get the 2 from?
On the first graph.
You look at the graph, right? The shape of the graph. Does the graph keeps on going up? If you extend it, does it keep on going up?
Yeah.
Okay, does it keep on going down?
Yeah.
Yeah, and doesn't stop, right? So what would you say if that happens? Going up forever, going down forever?
I forgot what you call it.
It's all real numbers.
Okay, why?
Can you say it out? All real numbers.
All real numbers.
Yes, okay. So if it's domain, right, then you look at left and right. It keeps on going to the right. But then when you try to go to the left, it's being stopped by the asymptote line. It doesn't go past, like, it doesn't go to the left to negative side. So that's why it's greater than 0. Right, Angela, x-intercept?
Is it 1?
Yeah, 1, comma,
0?
0, yeah, okay. X-intercept, we have a point here, right? X-intercept crosses the x-axis. Okay, y-intercept, Eric?
Sorry, I couldn't. Excuse me, I couldn't find the unmute button. It's 1, right?
Y-intercept, y-intercept.
Oh wait, there's none.
Yeah. Okay. So if you compare the chart on the top, on the top here, right, for the exponential and the log, you can see all the x and y are swapped, right? Used to be y equal to 0 for asymptote, now it become x equal to 0. Used to be the domain, right? Domain is real number. Now the real number become the range, right? This one. Okay, and then used to be y greater than 0. Now it becomes x greater than 0. Same with the intercepts. X-intercept used to be none. When you inverse, become y-intercept is none. Right, so you can just, if you remember the original exponential, then you would know the log one. Okay. Right, please raise your hand if you finish this whole table. So for the log graph, basically they will need you to know, like, to match which one is, which direction it's going, okay? And then they only do a simple transformation to it. Either you move it to the left, move it to the right, up or down, okay? Usually they don't do too much of stretching. All right, so let's take a break for about 15 minutes, and then we are starting book 2, okay? So make sure you have your book 2 ready, stand by.